Students, today we're going to do 11.5, which is quadratic functions and their graphs. So remember, quadratic means that we have the variable x is going to be raised to the second power, and a function is where we have inputs that each input maps to only one output. So there aren't two possible outputs for any one input. Okay. The most basic quadratic function is that our function of x is equal to x squared. Okay. When we have this very basic quadratic function, you notice that when x is 0, our function is equal to 0. And when x isn't 0, our function is equal to whatever x is squared. And in that case, when x is a positive value or when x is a negative value, it's actually going to take, our function is going to take on a positive value, because when you square something, it always makes the end result positive. So for that reason, our graph becomes this, this mirror image. Over the y-axis, okay? There are some variations to quadratic functions that we're going to want to learn how to graph, okay? So this graph can be moved vertically, up or down. It can be moved horizontally, left or right, and it can be made wider or narrower, and it can also be flipped upside down, okay? So those are our shifts. We can shift vertically or horizontally. There's two ways we can shift, and then we can become more narrow or widen, and we can flip upside down. So let's take a look at each of those individually. Here we have a slightly more complicated function. We've got our x squared plus 2. So this means that after we evaluate the squared part, at the very end, we're going to add something to our result. So you can kind of imagine what happens if you take this function in red and we add 2 to every y value, right? It's going to shift this guy up by 2. All right. So the vertical shifts are done by adding or subtracting a number after the squaring happens. Okay. After everything happens, if we add, it will shift us up. If we subtract, it will shift us down. Okay. But then how do we shift horizontally? Well, to shift horizontally, we are going to add or subtract directly to our variable before anything else happens to our variable. Okay. So here it's actually going to be slightly counterintuitive. Notice when we shifted vertically by adding 2, we shifted up 2. Here it's a little bit different. Here you want to imagine our parabola turns a corner. Its lowest point, the lowest point of the parabola happens when the thing being squared is a 0. Okay. So the lowest point of our parabola, what we call our vertex, or where it turns, is going to happen when this thing is a 0. But this whole thing being squared is going to be 0 when x is a -1. Okay, so you can see that bottom part, that vertex, is going to occur when x is at -1 now. All right. So this, by adding something to x before we do anything else to it, it's going to shift us to the left. Okay. If we subtracted from x, you can imagine that would shift us to the right. So our vertical shifts are intuitive. If you add, you move up. Our horizontal shifts are slightly counterintuitive, right? Because we're moving to the negative side, even though we're adding 1. But that you can reason that out to imagine the smallest that this squared thing can ever be is when this thing inside is 0, and that's going to happen when x is -1. Okay. So those are vertical and horizontal shifts. We can also flip this just by making the outputs all negative. That's going to happen with a negative sign. And we can also make our parabola wider or more narrow. So if we want it to be more narrow, meaning that it grows faster, so the output is y gets larger faster, we will just multiply it by a value. So here we've multiplied, we've put a coefficient of -3 out front of our squared term, and the negative has caused our parabola to flip upside down. Right now, all our outputs are made negative. We square our x, making this thing positive, but then we make it negative, so everything's negative coming out. And then this 3 basically makes our y values 3 times the size, so it stretches us vertically. You can imagine if instead of 3, we had, say, a 1/2, it would make our y values half the size and would actually compress us vertically or make it look wider. Okay, so those are the vertical shifts, horizontal shifts, and then any kind of flipping and stretching. And those are how they're done. Right. So we can do all 3 of those things at once if we want. We can shift to the left 1 by adding 1 to the x. We can shift up 2 by adding 2 afterwards. We can make our parabola 3 times as narrow by multiplying by a 3, and we can make it upside down by putting that negative out front. Okay, so all together, we can move our parabola wherever we want, upside down, right side up, and as narrow or wide as we would like. So let's make a shorthand for all these different kinds of variations. The general form of a quadratic function, okay, this is something you're going to want to remember. This is a graphing form. So sometimes we'll square this guy out and then simplify, but if you want to graph it, it's going to be in this form, okay? Here are A, whatever coefficient we have out there is going to tell us how much our parabola will narrow or widen by. Notice that this parabola, it technically has a 1 as the coefficient, and what that means is from the vertex, we'll step 1 to the side and 1 up. So that very first step is a 1 to 1, right? This guy here has a 3, so when we step 1 to the side, we're going to actually step 3 down. So that's how that parabola, that value A, can change the shape of your parabola. Okay. The H, so notice we're doing a subtraction sign here because we want to know how much we're going to shift right by, because that's the positive x direction. So how much you're shifting in the x direction is the H. So it's x minus whatever your H is. So notice in our case, our H is a -1 because we technically have x minus -1 here, and that's why it looks like a plus. But our H is really a -1, so we're shifting -1 in the x direction. So notice that about the general form. To account for that opposite nature of our horizontal shifts, we put this is a subtraction sign in our general form. Okay. That's how much we shift right by, and then our K, whatever we add at the end, that's how much we shift up by. So if K is negative, we would shift down. If H is negative, we would shift left. Okay. So then you can always say that your vertex is going to be at the coordinates x is H, y is K. If you look at our equation here, our H is a -1. Our K is a 2, so our vertex is at -1, 2. That's where we turn around. Okay. All right, so that's quadratic functions. Let me just give you guys a couple examples of how we would graph these 4 quadratic functions. Okay, let's take a look at this example here, where we've got this quadratic function, f of x is -4x, or x minus 4 squared plus 1. So we want to identify our h and our k. So our h is going to be a 4, and our k is going to be a 1. And then we want to identify whether we have any stretches or not. So our a is just a 1. It's not going to be stretched at all. So when we go to graph this guy, our vertex is going to be at HK. So it's going to be at 4, 1, which is 1, 2, 3, 4, and 1. And so we have no stretching or flipping. So that means that from our vertex, our next points, when we go 1 to the right, it's just going to move us up 1. And when we go 1 to the left, it's just going to move us up 1. So this is just a little 1 over 1 up, and that's because a is 1. Right. And then we can just use that kind of as a guide to draw our parabola. All right. So that's what the graph of that guy is going to be. It has a vertex at 4, 1. Let's take a look at the next example. Or let's just do one more. I don't think we need too many more. So another example is, let's do f of x is 1/2 x plus 2 squared minus 5. So here our h, remember in our general equation that we looked at, it says we've got a times x minus h. So if we were subtracting something from x here, we would be subtracting a -2. That's how it comes to be that we're adding 2. It's the same thing as subtracting a -2. So our h is -2. Our k is going to be -5. And our a, notice, is this 1/2. So when we go to graph this guy, our vertex is going to be at -2, -5. So it's going to be here, right? And our a being 1/2 means that when we first step just 1 to the right, we are actually only going to increase by a 1/2. Okay. And when we first step just 1 to the left, we are also only going to increase by a 1/2. So notice how we're not increasing by a whole 1. If a was 1, we would come up to here. But since a is 1/2, we're only increasing by a 1/2. And so that's why this parabola is going to be opening twice as wide as our other parabolas. Okay. All right. And now some questions you might want to ask yourself is, okay, but like, where are we going to cross the x-axis? That's a very good question, and I'll show you guys that in our next video.